Throughout this course, we've tried to introduce you to most of the many exciting and dynamic applications of fluid mechanics. We've talked about gearboxes, engines, race cars, and airplanes with the hope that it will help stimulate your curiosity and interest in fluid mechanics. Today we're going to talk about a subject that on the surface may seem a little more mundane, and that is pump and piping systems. Most of you probably don't spend a lot of time outside of this class thinking about pumps and piping systems because most of what they do in everyday life is in the background. For the most part, we aren't even aware of them, with the exception of those rare circumstances when they are needed for an emergency circumstance. You'll know what I'm talking about if you've ever had to clean out a flooded basement using a sump pump. As it turns out, pump and piping systems are being used around us all the time. The world as we know it would hardly be able to function without them. To name just a few applications, municipal governments are typically responsible for requiring water treatment and supply to all residences and businesses throughout their water mains. The treatment of water at the plant, as well as supply to buildings throughout a city, both require an input of head from the large-scale pumps. Piping systems are also required for wastewater drainage and treatment. Similarly, most other types of plants will require pumps for at least a few applications. As just one example, power plants use pumping systems for heat exchangers and to recycle recaptured steam water. Any refrigeration unit, large or small, requires a pump or compressor to cycle refrigerant through the system. Most engines require a pump to move lubricating oil throughout the system to all components. In fact, most of the machines and vehicles we saw in the previous reality checks are dependent upon pumps for everyday operations. Oil refineries and transport pipelines are dependent on pumps to move crude oil and refined oil throughout their plants and throughout the world. Water systems for irrigation and other farming applications depend on pumps and pipes for distributing water all over a vast area. Clearly, the modern world as we know it could not exist without pumps and pipes.
The King Street Water Treatment Plant is one of two plants that supply water for the city of Kingston. The other is the Point Pleasant facility in the west end of the city. Water is drawn a kilometer out at a depth of 80 meters from Lake Ontario and provides over 90,000 cubic meters a day capacity. The Point Pleasant facility has recently been upgraded to increase its capacity from 25,000 to 90,000 cubic meters a day in order to supply the increasing needs of the west end of the city. The city also runs on a combined grid system, so that in the event of one plant failing, there are other plants that can support the full grid. The water drawn from Lake Ontario enters a surge chamber, and from there it is drawn into the low-lift building. There are 4 low-lift pumps, 2 electric and 2 diesel, so that during a power outage the diesel pumps still run. This facility contains high-lift and low-lift centrifugal pumps. The low-lift pumps are a high volume with a low pressure rise, and high-lift pumps are the same high volume but with a high pressure rise to reach the municipal supply pressure. The low lifts are single stage, whereas the high lifts are 2-stage to get the higher pressure rise to service the distribution system. A 2-stage pump is essentially 2 pumps in series built into the same casing. In this building, you can see the low lift pumps. We'll see the high lift pumps later on. Pressure at the pump suction has to be high enough to avoid boiling the water inside the pump when the velocities go up. Cavitation, boiling and collapse of bubbles, can damage the impeller and make a lot of noise. Putting the low-lift pumps in the basement gets them down to a lake level and increases the suction pressure. This room is known as the pipe gallery. On the back wall here are the filters. Flow meter and flow control valves on these pipes control how much water passes through the filter, and also control the backwash that cleans the filters and filters the flock to waste. The backwash water is unchlorinated water from the clear well and essentially pumped using low-lift style pumps, high capacity, low pressure, back through the filters. The backwash water is unchlorinated water from the clear well, which is pumped using a low-lift style pump, i.e. high capacity, low pressure, back through the filters. Clean water leaves the filters and goes to the clear well. A disinfectant, sodium hypochlorite, is added to the clean water in the clear well. This kills any germs and bacteria from the water. The clear well gives the water the required contact time with the sodium hypochlorite. Clean water is then passed to the high-lift pumps. These large pumps pump the water into the distribution system. There are 5 electric high-lift pumps that pump the domestic water, including an electric diesel hybrid that pumps during power outages. There are also 2 solely diesel high lifts. If one or two of these high lift pumps were to go down, there is plenty of redundancy built into the system to maintain adequate water supply to the city. High lift pumps 1 and 2 are nearly 100 years old, which shows the durability of this proven technology. Both high and low lift pumps are double suction. That means the intake port, the suction, splits in two so the flow goes into the impeller from both sides. By balancing the momentum of the flow, this eliminates the thrust force that would be on the shaft of a single suction pump. Lower stresses and no need for big thrust bearings. Centrifugal pumps won't work unless you prime them. If they are full of air, they just don't generate enough suction to draw water into the pump. Priming the pump means filling it with water to get it to work when you start it. The high lift and low lift pumps are primed by vacuum pumps. Vacuum pumps create negative pressure. They are attached to the reservoir tank where there is always negative pressure. The tank is then plumbed into each one of the high lift and low lift pumps. Once the vacuum pumps have primed a high lift or low lift pump, the pumps are ready, filled with water at vacuum pressure. A good analogy is to think of a straw filled with water with your thumb over it. You don't need to do anything to maintain the volume. If there is any leakage in the system, then the vacuum pumps turn on for a few minutes to return the system back to its negative pressure setting. The high lifts supply the water to 3 main headers that leave the facility to the west, the east, and the north and supply the city. The headers are interlinked via a network of pipes and valves in the lawn just outside the facility, so that in the event of a line breaking, it can quickly be isolated. This system was introduced after the 1980s when a diesel-driven line broke and flooded the whole back parking lot of the facility. The check valves you see here prevent water flowing back into the pump from the distribution system. If these check valves fail to close and water flows back through the pumps from the system, the water flow will spin the pumps backwards like turbines, possibly at uncontrolled and damaging speeds. So, as you can see, pipes and pumps are critical to our daily showers and cooking, things that we take for granted. Some of the best engineering is in systems that work so well, 24/7, 365, that we never even notice.